Welcome to aminacademy.com. In physics, we'll discuss about dynamic lift and airfoil. Dynamic lift is the force that acts on your body, such as airplane wing. A hydrofoil or spinning ball, by virtue of its motion through a fluid. In many games such as cricket, tennis, baseball, or golf, we notice that a spinning ball deviates from the parabolic trajectory as it moves through air. This deviation can be partly explained on the basis of Bernoulli's principle. Dynamic lift is the force that acts on your body by virtue of its motion through the fluid. It can be defined as the force which acts on a body such as an aeroplane, wing, hydrofoil or spinning ball by virtue of its motion through the fluid. These are the examples for dynamic lift. Now, when ball moving without spin, look at here, this ball moving through the air without spinning itself. The streamlines around a non-spinning ball moving relative to a fluid. From the symmetry of streamlines, it is clear that the velocity of the fluid, that is air, above and below the ball at corresponding points is the same, resulting in zero pressure difference. The air, therefore, exerts no upward or downward force on the ball. That is here, there is no downward upward force on the ball, but the second case, the ball itself spinning. Moving with spin. A ball which is spinning drags air along with it. If the surface is rough, more air will be dragged. It shows that streamlines of air for a ball which is moving and spinning at the same time. The ball is moving forward and relative to it, the air is moving backward. Therefore, the velocity of air above the ball relative to the ball is larger and below it is smaller. The streamlines thus get crowded above and ratified below. This difference in the velocities of air results in the pressure of difference between the lower and upper phases, and there is a net upward force on the ball. This dynamic lift due to spinning is called Magnus effect. Now, what is Magnus effect? The Magnus effect is an observable phenomenon commonly associated with a spinning object moving through a fluid. The path of spinning object is deflected in a manner not present when the object is not spinning. The deflection can be explained by the difference in pressure of the fluid on opposite sides of the spinning object. The Magnus effect is dependent on the speed of rotation. Next is we'll discuss about airfoil. Here, an airfoil or aerofoil is the cross-sectional shape of an object whose motion through the gas is capable of generating significant lift, such as a wing, a sail, or the blades of a propeller, rotor, or turbine. Foils of similar function designed with the water as the working fluid are called hydrofoils. It shows that the aerofoil, which is a solid piece shape to provide an upward dynamic lift with it moves horizontally through air. The cross section of the wings of an aeroplane looks somewhat like the aerofoil with streamline around it. When the aerofoil moves against the wind, the orientation of the wing relative to the flow direction causes the streamlines to crowd together above the wing more than those below it. The flow speed on top is higher than the below it. There is an upward force resulting in a dynamic lift of the wing, and this balances the weight of the plane. Here, due to airfoil, there is lift is created. Due to that lift, the flight goes up and balance it and move forward. Here, look at here, this upward airfoil, this is a downward airfoil. By balancing this, the flight can lift up and balance itself and move forward. So far, we have done Magnus effect as well as dynamic lift airfoil. We have done. Please subscribe our YouTube channel.